Hello everybody, and welcome back to the PoorMansChemist. In this video, I am going to be making Thallium 1 Perrhenate, or Thallus Perrhenate, whichever you prefer, for no other reason than because I can. And because there's almost no information about this compound on the entire fucking internet. It is exceedingly difficult to find out anything about this shit. I want to give a massive thanks to, and brother, if I mispronounce this, I'm so sorry, but Typey Hapo, if I fuck that up, I apologize. It's on the screen. But this person, I put out a call on YouTube in the community section, you know, calling all chem peeps, can anybody find the solubility of Thallus Perrhenate? Because I can't find it anywhere. And dude was able to send me a paper that was in Russian that had a precious few figures of solubility data for Thallus Perrhenate. So it's a little bit less soluble than cesium perrhenate, so it should be very easy to separate Thallus Perrhenate from any excess barium that ends up in our final solution. Just by bubbling a little CO2 through it, the barium carbonate will crash out. It can be filtered while hot, and the thallium perrhenate will be just fine. I decided to go about making this stuff in a way that should give us I wanted to make it as pure as possible. I found a paper that said that thallium perrhenate is supposed to be strongly luminescent at 400 nanometers. Not really sure what that means, but, you know, hey, I've got a UV bulb. We'll give it a shot, see if it glows for us or not. And maybe it will crystallize beautifully like the cesium perrhenate did. So we've got 1.85 grams of ammonium perrhenate here, 2.04 grams of thallium 1 sulfate, and 1.32 grams of barium hydroxide octahydrate. The barium is slightly in excess, and the only reason it wasn't closer to the 1.27 grams it is supposed to be is because these crystals are big, and this shit is highly hygroscopic, and the humidity is sky high out here this morning, so I didn't want the bottle open for very long. Barium hydroxide forms barium carbonate readily. Will barium carbonate fuck up what we're trying to do? I don't know. I mean, as far as I can tell, carbonate should deprotonate ammonium ion, and we should be able to remove all of the ammonium ion as ammonia gas. It'll just bubble it out. It'll just boil it, or bubble out of solution. Well, it'll come out of the solution when we boil it. Sorry, too much coffee this morning. The first step, though, is going to be to create a solution of thallium 1 hydroxide with a metathesis between thallium sulfate and barium hydroxide. So, in theory, once we do this, our solution of thallium hydroxide can be added to this. The hydroxide will deprotonate the ammonium ion. That'll give us water, ammonia, which will be degassed as we boil the solution, and thallium 1 perrhenate. So, no contamination, no bullshit. It's awesome. Now, the reason that I'm doing such a small amount is twofold. Well, it's the same reason, but it's for two things. And it's only because I only have 1.85 grams of ammonium perrhenate. But also, as I've come to discover, I made this from my rhenium recycling, and I couldn't figure out why it got such a small amount. I was like, what the fuck? So I started boiling down all of the rhenium recycling, you know, to get the volume down as little as possible so that I could borohydride it again, because I knew it all had to be in there still somehow. And as you can see on the screen, what do you know? I leave that shit sitting overnight. Cesium perrhenate crystallizes out of that motherfucker all over the goddamn place. This stuff is a lot more indestructible than I thought that it was. Clearly, this is all of the rhenium that was in my recycling that wasn't cesium perrhenate. So, how am I going to destroy the cesium perrhenate? I'm not 100% sure yet. I think I'm going to evaporate everything down, and you can see it over here. I've got it going. There's no crystals in it now because it's been evaporating down for a while. You can see I've got it down to about 300 mils here, so we're getting there. Evaporate it down, let everything crystallize out, filter them out, dissolve them in fresh water, add a little bit of HCl, and then borohydride the bejesus out of it. I found a paper that says that when you reduce perrhenate with borohydride, you end up with a mix of rhenium metal and lower oxides, but who the fuck cares? Because they will all dissolve in hydrogen peroxide just fine. I've just got to get the cesium ion out of there somehow, because unless that's gone, man, I think we might just continue to have this problem. But on the other hand, at least we've identified what the mystery crystalline substance was in the rhenium recycling. It's cesium perrhenate. I swear to God, man. And here I was like, oh my God, it crystallizes beautifully. Let's make this shit over and over and over again. Now I can't fucking kill it. So just FYI, man, if you make any cesium perrhenate, prepare for it to fight back when you try to recycle it. Anyway, let's get this show on the road and see our thallium perrhenate. Everybody, there is our solution of thallium hydroxide. There is some barium sulfate that for whatever reason would not centrifuge out no matter what I did, but I'm not stressing over it because we're going to end up with a little bit of barium carbonate anyway. We're going to have to centrifuge it later once I've reduced the volume some and made it more manageable. So I'm going to go ahead and add in the ammonium perrhenate now. I don't expect any visible reaction to happen at this volume. Make sure we got it all in there. Okay. Alright. And so now we just need to heat it with stirring. Let the hydroxide react with the ammonium ion, convert all of that to ammonia, drive it out of solution. Just stirring it and heating it like this is going to convert the excess barium carbonate, or barium hydroxide rather, to barium carbonate. And wow, okay. I think our thallium perrhenate just dropped out of solution. No matter, that's fine. It's not hot right now, so that's, well, I guess that's not the worst thing in the world. At least we know we won't have any problem getting it to crystallize later, right? Yeah, this is a lot more insoluble than the cesium salt. I mean, well, we saw that on the chart, but still, damn. All right. But, again, referring back to the chart, we saw that once the water temperature goes up, the solubility of thallium perrhenate goes way up. So I'm not anticipating this being a problem. So I'm going to let this heat and spin, and I will come back when there's something to report to you guys. Okay, watch this, y'all. This is pretty cool. Watch. Turn off the stirring. This stuff is a finely dispersed powder, but watch how fast it will settle out. It settles out so quick that at first I thought maybe there was just bubbles or something in the water, or it was I didn't even know what. Maybe the barium sulfate that was on the surface of the solution. But no, that's our stuff. Look at that shit. I mean, that even as a fine powder, that just settled right out, no problems. This stuff is one of the heaviest compounds I've ever seen. That is so cool. All right, everyone. It is the next day. I had to transfer this into a bigger beaker just to try to get all of the precipitated solid to dissolve. Transferred it to that, heated it up for a little while, and then, of course, put it away last night when I finally had to go to bed. And I come out this morning and I find this beautiful layer of little crystals has formed on the bottom of the beaker. And take a bit of a closer look here and see. Doesn't look much like cesium perrhenate did. It's definitely less soluble. I think maybe the crystals form kind of quickly, and so they just don't really have a lot of time to grow. I don't know. I mean, we've seen cesium perrhenate crystallize out in a kind of similar fashion. So it wouldn't surprise me if thallium perrhenate ends up, as we evaporate it down and work with it, if we start getting some different crystals out of it. But this is the only type of crystal I've seen coming out of this compound thus far. Just these tiny little crystals that are really too small to see with the naked eye to tell what their morphology actually is. They're very sparkly, though. I know it doesn't show up really on the video. Maybe if I try to turn it here. Very pretty. So, the plan here, I guess, is to heat this up and evaporate it down some more. And then I'd like to decant off the solution. I'm wondering if it isn't a good idea to just, no. There's still going to be a good amount dissolved in there. Yeah, I think what I'm going to do is evaporate it down some more. We'll let it crystallize again. We'll sacrifice some of it just by decanting off the liquid so that we can get rid of the excess thallium hydroxide and any of the barium sulfate that's in there. Hopefully this stuff will crystallize faster than barium sulfate can settle out. There's only a teeny tiny amount of barium sulfate in there, but I hate it, and it's just bugging the crap out of me that it's there, and I really want to get it out of there. So anyway, I am going to evaporate this down some more, and I will come back when there's something else to show you guys. Oh, shit. Goddamn, don't spill thallium on your hand. Fucking Christ. Okay, so I evaporated down the solution a little bit. I chilled it in ice water that I had added some salt to drop the temperature down even more. I then decanted off all of the solution and transferred that to thallium recycling. And then I boiled some fresh distilled water and transferred all of the solid into here. Had to add quite a bit of water to get it to dissolve, even at boiling, and it is all in solution now. So the plan is to let this evaporate down a little bit, and then as soon as I start seeing evidence of solid appearing, I'm going to let it cool and form some bigger crystals, hopefully like it looks like it made last night. If it cools slowly, hopefully I can get some decent sized ones that will be easy to filter, and then we can wrap this experiment up. So I will come back when there is something else to report. Alright, so I can report this about thallium perrhenate. If you get it all to dissolve in a large amount of boiling water, for being as insoluble as it is, it tends to supersaturate. if you cool it in ice water, again, this ice water I've added salt to, so it's good and cold, and just stir it gently, just about like that. That really facilitates it crystallizing out a solution. I've just finished stirring this for a while. This is getting down to less than 10 degrees C in there. So I think we've got all we're going to get. We got a good bit of it in there. So the plan here is to decant off the solution, and I'll decant off as much as possible. I will pipette the remaining bit off using a glass pipette, and then I will just put the beaker with the solid in it in the desiccator to dry, so that there is the absolute minimal amount of losses possible, because this is not a cheap compound to make. So I will come back once this stuff is dry and we have something to look at. Okay, everybody, this stuff has been sitting in the desiccator overnight, and it should be damn good and dry by now. Yeah, it sure looks it. It is not much to look at, but still, it is an exceptionally rare fucking compound that is mentioned almost nowhere on the internet. There you go. That is it. Perrhenate. I tell you what, man, I love doing these kinds of preps. This is why I built my lab in the first place, is to see weird-ass compounds like this that are only mentioned in a few places in like old literature, that there's almost nothing out there about, and that I would never see if I didn't make them myself. So anyway, I figured I would show you guys how I actually do getting the thallium compounds from the beaker into the vial. It's a little messy. If it all goes tits up, at least the doctors in the emergency room will have a video of what I was doing to be able to watch to try to figure out. I don't know, they won't be able to find any information on this compound either, so I'll probably be just fucked. And hey, Doc, if you are watching this, don't be talking down to me. You're going to get at least one paper out of this for sure, so you just fucking cool it. Anyway, let's see. Oh, it is I expected it to be more granular. It is very powdery. Very powdery. Now, dust is a very big hazard when it comes to thallium compounds. This powder is exceptionally heavy, so it doesn't look like it's going to be eager to produce dust, but I would imagine that it will if properly motivated. Dust is, if you breathe the dust, that's one of the worst case scenarios. That is one of the worst things that could happen. Getting it on your skin is not the end of the world. You don't freak out. You just calmly get everything to a good stopping point, efficiently, and you go and you wash your hands or whatever the hell it got on. You decontaminate it, as soon as possible, and you go on with your day. You're fine. Trust me, this has happened to me on numerous occasions. The exposure is small. You're fine. Now, if you cover a large area with skin, even with a dilute solution, that's a medical emergency, because then even though it only absorbs a little bit, it's across a large area. So, yeah, important safety tip. All right, here comes the most dangerous part of this enterprise here. Although this is turning out to be very, very easy to work with. Like, God, holy crap. Okay, this was not really a good one to show you guys, because that was stupidly easy. It is usually not as clean and easy as this. This is not a good example. Oh well, hey, we got it. Let's take a look at this shit. And there we have it, people. I have discovered one property about this stuff. It's not terribly unexpected with it being a dry, fine powder like this, but it definitely is capable of some static cling. I was going into the shed with this and tripped and fell. The vial was, capped and it's sealed. It's fine. I caught myself as I fell, but of course this powder dumped up the freaking side of the vial and now is stuck to it, and it does not look like it is ever going to come off. So that's something. But yeah, that could be a hazard, just because if it's capable of, static, making it stick to stuff, it could stick to your hands and you might not notice it. I just went and washed my hands with soap and water. Whenever you're working with thallium, you do OCD hand washing anyway, just to be on the safe side. But still, yeah, that's a potential danger with this. I went in the shed with it to check and see if it is fluorescent. It is not. Not in the slightest, at least not under the germicidal UV lamp, which tends to make everything else that's fluorescent glow, and I think is actually the cause of my phenolic resin polymerizing in the jar. I didn't even think about UV light hitting it and that really high energy UV light coming off that bulb when I checked to see if stuff is fluorescent. It definitely shone on the jar several times, so maybe that's what's happened to it. Oops, little oversight there. Clearly, be careful with the high energy UV light. Anyway, still, we prepared a compound that is mentioned almost nowhere in the fucking internet, as rare as hell. You are absolutely never going to see this compound anywhere else, or probably even hear it mentioned. But of course, as always, I'm the only person that works with thallium, so yeah, that right there, you'll never see this shit anywhere else. Even though thallium is pretty easy to work with. Anyway, definitely not for beginners, though. So yeah, I mean, compounds like this are why I made this channel. I love this so much. It might just look like a boring white powder to you, but I know what it is, and it's fucking glorious, man. This is exactly the kind of shit I've always wanted to see. There it is. And I mean, if we hadn't made it, we'd have never seen it, ever. We'd have gone our whole lives without seeing this. And if the thought of that doesn't bother you, you might be on the wrong channel. Oh, that is so awesome, man. Damn. See, sex with the universe, it is so gratifying. And it's kind of sparkly, too. It's so pretty. Oh, it's so great. It's so glorious. Well, anyway, I'll stop having my chemgasm all over the place here. If you guys like that video, give it a thumbs up. If you didn't like it, I kind of feel sorry for you, actually. Subscribe, comment, share the video, donate a few bucks if you enjoyed this and you like seeing shit like this. And until the next one, y'all, I will see you later. God, it's so fucking awesome. It's beautiful. Beautiful. Like a fucking chemistry brain baby. Oh, I love everything about it.